Welcome back, grade 11s. This is our second and final example in simplifying this type of fraction. One term over one term. Key thing to look at. The next examples will be multiple terms and we'll have a slightly different approach. But the one approach that will definitely be the same is we want to have prime bases. So each of these numbers, 12, 18, 27, and 8, we want to write as a product of prime numbers. So 12 we can write as 2 squared times 3. In other words, 4 times 3. And your calculator has a nice little shift fact button to use if you'd like to see that. So that's to the end. So that's the first part here. Then we're multiplying. If you saw the last one, you would have known I'm a fan of these time signs, the old-fashioned ones, not this dot over here. So 18 we can write as a product of, well, it's 2 times 9. So that's 2 times 3 squared, where every base now is a prime number. And that's to the n minus 1. Okay, over 27, well, that's 3 cubed. And as you start doing these, you start recognizing the numbers and going, 8, well, I know offhand 8 is 2 cubed. I don't need to reach for the calculator or double check it. And that's to the power of n minus 1. Okay, equals. As I'll keep saying, many ways to do this. If something cancelled so nicely, I'll do it straight away now. But otherwise, I'm just going to look at the numerator and look at bit by bit. So I'm going to look at this first bracket here and go, well, I need to multiply this n in. So this is raising a power to a power, so I need to kind of do it to each of those. So that's 2 to the 2n times 3 to the n. And we're going to do the same for this over here. So this n minus 1, we need to kind of do to each of these bases. So in the first case, we've got 2 to the n minus 1. And the second one, we've got 3 to the 2n. And I'll always say it, just keep your eyes out here because it's easy to make a mistake. 2n minus 2. Because we're multiplying that 2 by n minus 1. So we need to distribute the 2. So just keep an eye out for that one. Then we've got the denominator. Nothing to worry about there. 3 to the 3n. And some of you, I'm sure, will just write 3 to the 3n straight up. That's fine as well. And for the next one, again, just keep an eye out. 3n minus 3 because we're multiplying that 3 by n minus 1. 3n minus 1. So we need to distribute it into each of those terms. Okay. I like to do this way and go, well, you know what? I'm just going to simplify the numerator. There's a 2 and a 2 there. So if we're multiplying and the bases are the same, keep the base the same, add exponents. 2n plus n minus 1 is 3n minus 1. Times 3, well, we've got 3 to the n times 3 to the 2n minus 2. That's 3 to the 3n minus 2. Simply adding exponents. Now in the denominator, there's nothing to do. And possibly risky in moving things around because possibly we'll make a mistake. But I'd like to just line these up. So I've got 3n minus 3 times 3 to the 3n. Because multiplication is commutative, we can multiply in any order. Now things are lined up nicely so we can simplify. Now we've got the base is the same, one term over one term, so we can just subtract exponents. So our base is going to stay the same, 2. But we're going to go 3n minus 1 minus 3n minus 3. So be careful. I've got myself a nice little bit of working space here. And I'm going to go, wait a second, I need to go 3n minus 1 and I need to subtract that entire exponent here. So just be careful because that's 3n minus 1. We're subtracting the 3n, but because we're subtracting negative 3, effectively that's the same as adding 3. So just be careful, minus 1 plus 3 is actually 2. Now the 3n's, those kind of like cancelled, if you will, because they equal 0, but we've got 2 squared. Now, for the powers of 3, we've got a similar thing going on. 3n minus 2 minus 3n. Well, that's just 3 to the minus 2. Now, I don't know how far it says simplify. So I guess we could interpret what that is or say, well, we've simplified quite a lot now. Well, that's 2 squared. And to be honest, I'll just plug in the calculator and go, well, that's 4 over 9. That's what the calculator is going to tell you. But let's understand it a little bit and say, well, 2 squared is going to remain on the numerator, and 3 to the minus 2 we can write as 3 squared in the denominator because we multiply. So that we could simplify to 4 over 9. But the hard work was over here, prime factorizing the bases, multiplying those exponents in, subtracting, and we got our final answer. Okay, that was it for those types of examples. Next examples will have multiple terms. I'll see you there.